Alright, today we're going to be talking about polyatomic ions. So polyatomic ions means many atom ions. So we've been dealing with ions that are a single element, like sodium is Na+1. But there are also ions that have multiple atoms or elements within the ion. Luckily for you, you don't have to memorize it. We give you all the polyatomic ions that are common on the back of your periodic table, and you get to use that. So it's not something you have to memorize, you just have to know how to use them. So an example of a polyatomic ion would be like SO4 minus 2. And so SO4 minus 2 is what we call sulfate. I just want you to notice this whole SO4, you kind of use it, it's like basically one ion that's composed of different atoms, sulfur and oxygen, and the whole thing has a -2 charge. So just treat it as an ion, but it just happens to have multiple elements. So if you look at the back of your periodic table, you'll notice that all the polyatomic ions are anions except for one, which is positive, a cation. That's ammonium. So most except for one polyatomics are negative. When we name them, we use the same rule, except we don't add IDE. It's already has its name, so we just keep that particular name. For example, Na2SO4, so your cation is Na, your anion is SO4, so that's polyatomic. So we would name it sodium, and then what we would do is you just look up SO4, and SO4 is sulfate, so it'd just be sulfate. So we wouldn't add sulfide, it would just be sulfate. Okay, so that's different than Na2S, which is sodium sulfide. Now, in this case, because it would be sodium with sulfur, we change it to IDE. But if we have a polyatomic, we just keep the name that's given to us on the back of the periodic table. So there's two types of ionic compounds. The first is called binary. Binary, the word bi means two, right? Like a bicycle. And so this is when two elements form an ionic compound. And so examples like sodium chloride, sodium oxide, they all end in IDE. And notice, like, there's two elements, right? And here's sodium and chlorine, sodium and oxygen. Ternary means there's three elements forming an ionic compound. So it has to include a polyatomic. And so what we mean is, notice your cation on your metal is this, your anion is OH, right? But notice there's 1, 2, 3 elements. Here you have 1, 2, 3. So they always have to include a polyatomic to get the second and third element. So that's what a ternary is, compound. Alright, so we're going to name these polyatomic ions. The first one is, so I always determine what's the cation. So in this case, the cation is barium. So that makes this last part a polyatomic. The second, you could also say, hey, this is a ternary, right? Because it has three elements. So ternary means that that there's a polyatomic. So the first is barium, and then I know, okay, this is a ternary, so I have to look at my list there, and find SO4. And if I find SO4, I find that the name is sulfate. Same thing here. This is ternary. So ternary, this is strontium, and then we'll talk about why there's parentheses and all that good stuff. But if I find NO2, that's nitrate. This is actually bigger than ternary. It actually has four. Well, it has three elements. So I guess you'd call it ternary. Nitrogen, hydrogen, and oxygen. This is actually the only polyatomic. So and this has to be the anion. So if this is the cation, this is the anion. Here's a cation, so the rest has to be anion. Here's the cation. Here's the anion. We know it's ternary. This one's a little tricky, right? Because copper, if you remember, is one of your multiple oxidation states. So I know it's going to be copper cyanide. However, which copper is it going to be? So cyanide. So let me just back up really quickly. So cyanide, Cn. The reason why we put parentheses here is because that we're saying there's two CNs. And we know that each cyanide is a -1 charge, right? So therefore copper has to be a +2 in order to neutralize, right? So this would be copper 2 cyanide. All right, so now let's go ahead and start writing formulas from this. It's pretty easy. Lithium we know to be a +1 charge. So here's lithium. And thiocyanate, just go ahead and look that up. So thiocyanate is SCN -1. They both have positive and -1 charges, so they'll be equal, so LiSCN. Ammonium fluoride. So if you look at ammonium fluoride, ammonium is the only positive polyatomic charge. It's NH4 +1. Now fluoride, is fluoride going to be a binary or sorry, is it going to be a polyatomic or monoatomic? In this case, because it ends in IDE, now not all things that end in IDE are monoatomic. For example, like hydroxide or peroxide, those are actually polyatomics that end in IDE, but a majority of ions that end in IDE usually are going to be your monoatomic. So this is going to be fluorine -1. They both have a +1 and -1 charge, so they'll end up like that. Magnesium and hydroxide, Mg +2. Hydroxide ends in IDE, but it's one of the few ones that end in IDE, and it's a polyatomic. It's going to be OH -1. So if we take a look at these two, you'll notice that they're not neutral. And you add one more OH from -1. In this case, we're going to use parentheses. And so, like if I wrote this Mg and then I want to say, hey, there's 2 OH, the problem is this 2 only refers to this H. But we're saying that there's 2 OHs. So in order to do that, we say Mg and then we put parentheses as if we're saying, hey, there's 2 of OHs, not just 2 H's. Okay? Aluminum carbonate. Aluminum is Al +3. Carbonate, notice it doesn't end in IDE, so I know for sure it's a polyatomic. I go to my polyatomics, look for carbonate. I find it's CO3 -2. So this is the one where I have to add multiples. So you'll see if I add this, I get -6 on this side, +6 on this side. So I have 2 ALs. And then 3 COs, 3. So I have to put in parentheses CO3 because I have 3 CO3s. And so that will be my answer there. Okay. All right, so here's your homework. Just want to note these top are just polyatomics, but then here's mixed practice. So it has everything that you would need to know for the quiz. And so ultimately you want to get to that point.